Hello everyone, welcome to this video lecture on Introduction to Network Layer IPv4 addressing special address ranges. Today we'll explore key IP address ranges reserved for specific purposes including loopback, broadcast and multicast addresses. These addresses play a crucial role in networking, ensuring efficient communication and network functionality. I am Vibhav and I'll be guiding you through this session, so let's get started. First things first, what is IPv4? Well, IPv4 or Internet Protocol version 4 is the fourth version of the Internet Protocol and it's responsible for uniquely identifying and enabling communication between devices on a network. It uses a 32-bit addressing scheme, which means it allows for about 4.3 billion unique addresses. IPv4 addresses are written in what we call dotted decimal notation. For example, an IP address looks something like 192.168.1.1, four numbers each separated by a dot. Each of these numbers represents an octet, which is 8 bits. Now, while most of us think of IP addresses as just identifying devices, there are actually some special address ranges reserved for specific purposes, and that's what we are going to explore today. So, what are special IPv4 address ranges? Simply put, they are specific blocks of IP addresses that are reserved for certain tasks, making network communication more efficient. These special addresses fall into three key categories. The first one is loopback addresses. They allow internal communication within the same device. The second one, broadcast addresses. These let us send messages to all devices within a network. And the third one, the multicast addresses. These are used to send data to multiple devices at once without flooding the entire network. Understanding these is essential for configuring networks, troubleshooting connectivity issues, and ensuring smooth data transmission. Alright, let's start with loopback addresses. They are used when a device needs to talk to itself. Sounds strange, right? But it's actually super useful for testing and local communication. The loopback address range is 127.0.0.0/8, meaning the first 8 bits are used for the network portion and the remaining 24 bits are for the host addresses, and any address from 127.0.0.1 to 127.255.255.255 is a loopback address. However, the most commonly used one is 127.0.0.1, which is also known as localhost. Whenever data is sent to a loopback address, it never leaves the device, it just gets processed internally. This is really helpful for testing network applications and making sure the TCP IP stack is working properly. So, how do we actually use loopback addresses in real life? Well, if you are a developer, you might use it to test client server applications running on the same machine. For example, let's try this in the terminal. So, if you run the command pinch 127.0.0.1, it will simply start displaying the packets which are sent and received on the device itself. So we can see the packets are reaching the destination, and here 16 packets are successfully transmitted and successfully received. Similarly, we have another useful command, that is trace route. If you run this in the terminal, it will help us to check how the data travels inside our own system. So when we run this command, it displays a single hop to the local host, since the packet never leaves the system, and in a single hop it reaches its destination. So that is what the local host is actually. So a simple analogy, using a loopback address is like calling your own phone number to make sure your phone is working. Now let's talk about broadcast addresses. They are used when you want to send a message to all devices in a network segment at once. There are two main types of broadcast addresses: the limited broadcast and the directed broadcast. The limited broadcast address is 255.255.255.255. It sends data to every device in the local network. However, routers do not forward these packets beyond the local network. The directed broadcast is when the network prefix is combined with all host bits set to 1. For example, in a 192.168.1.0/24 network, the directed broadcast address is 192.168.1.255. Unlike limited broadcasts, routers can forward these if configured to do so. So, broadcast addresses are commonly used for network wide announcements like address resolution queries. So, where do we see broadcast addresses in action? Here are some common applications. The Address Resolution Protocol (ARP). When a device needs to find out the MAC address of another device, it sends a broadcast ARP request to 255.255.255.255. Then comes the Dynamic Host Configuration Protocol (DHCP). So it is like when a new device joins a network, it sends a broadcast request asking for an IP address. And the third one is the network announcements. Things like network time synchronization and system wide alerts often use broadcasts to reach all devices quickly. Next up, we have multicast addresses. These are super useful when we need to send data to multiple devices, but not all devices. Mind you, not all devices. Multicast addresses fall in the range 224.0.0.0 to 239.255.255.255. Some notable subranges include 224.0.0.0/24, used for local subnet multicast, and routers don't forward these. Then comes the 224.0.1.0 to 224.0.1.255, which is used for multicast control messages across networks. Multicast works by having devices join specific groups, and routers use IGMP, Internet Group Management Protocol, to manage which devices get the data. Multicast is widely used in industries where data needs to reach multiple users efficiently. So, live streaming and webcasts, wherein universities use multicast to broadcast lectures to students. Then, financial data distribution is a good example. Stock exchanges use multicast to send real time market data to traders. And online gaming, of course, multiple player games use multicast to sync multiple player actions in real time, reducing network load and improving responsiveness. So, alright, let's quickly recap what we have covered. First one, the loopback addresses. They are used for internal device testing and debugging. The broadcast addresses, which are of two main types, limited and directed, which are used for network wide messaging. And the third one, multicast addresses. They are used for efficient data distribution to selected groups. Now comes the best practices. So, some best practices to keep in mind is to use loopback addresses for self testing and local application development. Be careful with broadcasts as they can generate excess traffic if overused. Optimize multicast for bandwidth efficiency and ensure proper IGMP management. And the last one, secure your network by filtering unauthorized broadcasts and multicast traffic to prevent congestion and misuse. So that's it for today's session. Hope this helps you better understand special IPv4 addresses and their applications in networking. Thanks for listening.